Welcome to Star Chat, the podcast that takes you on a journey through the vast expanse of space and time, exploring the wonders of the cosmos and our place within it. I'm your host, Carl, and I'm thrilled to have you join me on this adventure. As we gaze up at the night sky, we're reminded of the awe-inspiring beauty that awaits us just beyond our atmosphere. Tonight, millions of people across North America will have a chance to witness one of nature's most spectacular displays, the Northern Lights. Also known as the aurora borealis, this phenomenon is a result of charged particles from the sun interacting with our planet's magnetic field and atmosphere. Imagine, if you will, a cosmic storm brewing on the surface of the sun, where an eruption known as a coronal mass ejection unleashes a massive burst of energy into space. This energy travels across the vast distance between the sun and Earth, eventually colliding with our magnetic field and causing it to oscillate like a giant, ethereal harp string. As the particles from the sun dance along the lines of our magnetic field, they collide with atoms and molecules in our atmosphere, exciting them to higher energy states. As these excited atoms and molecules return to their ground state, they release excess energy in the form of light, creating the breathtaking spectacle we know as the Northern Lights. The colors we see, from soft greens to vibrant reds, are a result of the specific energies released by the excited atoms and molecules, a symphony of light that's both beautiful and mesmerizing. Tonight, residents in 18 states across the U.S. will have a chance to witness this natural wonder as the aurora borealis makes an appearance in the night sky. From Alaska to Maine and from Montana to New York, people will gather in quiet, dark areas, away from city lights, to marvel at the celestial display. As we appreciate the beauty of the Northern Lights, let's not forget the science behind this phenomenon. The sun's activity, which drives these spectacular displays, is part of an 11-year cycle, where its magnetic poles swap places and cause magnetic twists and tangles along the way. This reminds us that our planet is connected to the larger universe, influenced by forces beyond our control. As we continue to explore the wonders of space, let's also remember our responsibility to care for our home planet, to protect it from harm, and to preserve its beauty for future generations. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. We're diving into the fascinating world of space exploration, where scientists are constantly making new discoveries that challenge our understanding of the cosmos. Today, we're talking about a groundbreaking study published in Nature Communications, which reveals the first ever in situ and remote observations of the ultraviolet footprint of the Moon, Callisto, by the Juno spacecraft. Imagine being able to witness the interaction between a planet's magnetic field and its moons in real time. That's exactly what the researchers behind this study were able to do, using data from the Juno mission to Jupiter. By analyzing the ultraviolet emissions from Callisto, the team was able to infer the equatorial plasma density around Jupiter, providing valuable insights into the complex dynamics of the Jovian system. But what makes this discovery so significant? For starters, it marks a major milestone in our understanding of the Jupiter-Callisto interaction. By studying the ultraviolet footprint of Callisto, scientists can gain a better understanding of how the Moon's surface interacts with Jupiter's magnetic field and how that affects the planet's overall magnetosphere. The implications of this research are far-reaching, with potential applications for future space missions to the outer planets. By refining our understanding of the complex relationships between planets and their moons, we can better design and execute missions that will help us unlock the secrets of our solar system. So, what's next for the Juno mission and its team of researchers? As they continue to explore the Jovian system, they'll be on the lookout for more exciting discoveries like this one. And with the wealth of data still being collected by the spacecraft, it's likely that we'll see many more breakthroughs in the years to come. Stay tuned for our final story of the day right here on Star Chat. Welcome back to Star Chat. As we continue our journey through the vast expanse of space and exploration, I'm excited to share with you a fascinating story about how scientists are harnessing the power of spacecraft to forecast solar storms. You know, those powerful blasts of plasma from the sun that can potentially devastate our electronic systems here on Earth. Imagine being able to predict when a solar storm is going to hit, 15 hours before it arrives. That's exactly what a team of researchers, led by Emma Davies at the Austrian Space Weather Office, has achieved using the European Space Agency's Solar Orbiter spacecraft. By orbiting the Sun between 30 and 90% of the distance between our star and Earth, Solar Orbiter is able to provide an early warning system for these potentially hazardous events. Now, you might be wondering how this works. Well, it's quite clever, really. The Solar Orbiter measures the magnetic field and solar wind speed of coronal mass ejections, or CMEs, as they leave the Sun. This data is then used to model the internal magnetic structures of the CMEs, which allows scientists to predict the strength of the geomagnetic storm that will result when the CME hits Earth. In two recent events, on March 17 and 23, the team was able to make predictions about the strength of the storms 7 and 15 hours before they arrived. And the best part? Their predictions were remarkably accurate, matching the actual geomagnetic storm strengths closely. Of course, as Emma Davies cautions, this is just the beginning, and more observations will be needed to refine predictive models. But think about the implications of this technology. With advanced warning, we could potentially protect our power grids, communication systems, and other critical infrastructure from the damaging effects of solar storms. It's a remarkable example of how space exploration and scientific research can have a direct impact on our daily lives. As we gaze up at the stars, it's a reminder that we're not just passive observers in the universe, we're active participants, working to understand and mitigate the risks that come with being part of a dynamic and ever-changing cosmic landscape. So, let's keep looking up and let's keep exploring. The universe is full of mysteries waiting to be unraveled, and with each new discovery, we're one step closer to unlocking its secrets. That's all for today's Star Chat. Remember to like, share, and subscribe, and until next time, remember to keep looking up at the stars.